all the different types of urban infrastructure, water is perhaps the most overlooked and underappreciated. When we talk about urban infrastructure and water, we refer to the three waters, which is water services for water supply, wastewater, and stormwater, including both natural assets and physical infrastructure. The distribution of water on the Earth's surface is extremely uneven. Only 3% of the water on the surface is fresh. The remaining 97% is in the ocean. Of the fresh water, 69% resides in glaciers, 30% underground, and less than 1% is located in lakes and rivers. Looked at another way, only 1% of the water on Earth's surface is usable by humans, and 99% of the usable water quantity is situated underground. The water cycle consists of three major processes: evaporation, condensation, and precipitation. Evaporation is the process of a liquid's surface changing to a gas. In the water cycle, liquid water in the ocean, lakes, or rivers evaporates and becomes water vapor. Condensation is the process of a gas changing to a liquid. In the water cycle, water vapor in the atmosphere condenses and then becomes a liquid. Unlike evaporation and condensation, precipitation is not a process. Precipitation describes any liquid or solid water that falls to Earth as a result of condensation in the atmosphere. Precipitation includes rain, snow, and hail. The water cycle has a dramatic influence on the Earth's climate and ecosystems. Climate is all the weather conditions of an area evaluated over a period of time. Two weather conditions that contribute to climate include humidity and temperature. These weather conditions are influenced by the water cycle. The water cycle also has an influence on the physical geography of the Earth. Glacial melt and erosion caused by water are two of the ways the water cycle helps create Earth's physical features. Water is managed at three levels of government: the national, regional, and local. The main plans we use to manage water are the Auckland Plan, the Unitary Plan, the Long-Term Plan, and our Asset Management Plans. Together, they provide direction, development rules, finances, and work program that determine the Council's activities. They also affect what everyone else can do across the region. Let's start with drinking water. How do we use drinking water? In this graphic, we use a comparison between the average water use per day per person in 4 different cities in New Zealand and in Australia. As we can see, in Wellington, on average, each person uses 350 liters per day. That's an average of about 2 bathtubs full of water per person per day. Residents of Sydney are a bit more conservative with their water usage at 302 liters. In Auckland, we do a better job reducing consumption at about 272 liters. And in Melbourne, residents sip a mere 250 liters per day. The majority of this water is used for residential purposes. For example, we use 27% just for showering, another 23% goes to washing clothes, 18% gets flushed down the toilet, and 14% goes through the water taps. Aucklanders haven't always consumed so many liters of water per day. Consumption was a lot different 100 years ago, and also the source of water was quite different. 100 years ago, the sources of water were mainly from streams and wells. In 1865, the Auckland domain became a temporary source of water for Aucklanders. Then, Western Springs became the primary source of Auckland's water supply. In 1910, the first Waitakere Dam was completed. From 1950 to 1977, the Hunua Ranges were constructed, which became the main source of Auckland's water supply and continues to be to this day. Watercare is New Zealand's largest water and wastewater company. It supplies around 400 million liters of drinking water daily to Auckland. These waters are from 10 dams, 1 river, and 1 underground source. 60% of the water is produced from 5 Hunua dams, 25% from Waitakere dams, and 10% from the Waikato River. The remaining 5 from Ohanga wells. Other cities around the world are developing long-term sustainability plans for their water supplies. For example, by 2040, London will manage its rainwater sustainably to reduce flood risk and improve water security, maximizing the benefits for people, the environment, and the economy. This from the London Sustainable Drainage Action Plan. In the US and San Francisco, they want to optimize the use of their finite water and energy resources to balance community and ecosystem needs, creating a more resilient, reliable future. In Australia, the Cooperative Research Centre for Water-Sensitive Cities has supported stakeholders to develop transition strategies for different cities. Each city has defined its own vision with some shared aims. Currently, the vast majority of our water comes from dams. But by 2050, we will need to diversify the sources of our water to continue to meet demand. Fresh water is a scarce resource. Even though it rains frequently, we have limited large rivers, lakes, and underground resources in the region to draw water from, and we are becoming increasingly reliant on the Waikato region to meet those needs. In urban areas, water demand is forecast to outstrip current supply within 10 years, prompting planned additions to our existing water supplies. This is expected to meet our urban supply needs until around 2050, as you can see in this graphic, or longer if we can be more efficient with our water use. We need to evaluate a range of options for meeting our future water needs. This includes making the most of what we already have and potentially developing other new sources of water supply. Because our supply options within the region are very limited, the solution is likely to be a mixture of some or all of the following. More efficient water use, that is, reducing our own demand for water. Maybe watering our lawns less or washing our car a few less times. Rainwater collection and storage from rain tanks to reservoirs, and this can be done at the individual level with rain barrels at the end of water spouts. Other water sources in the region, such as aquifers and surface water, takes from rivers. Water reuse for non-potable and potable purposes, so we may use some gray water, water that's gone down the sink, to water the lawn or the grass or gardens, rather than fresh water. Water sources from outside the region may be imported to help supplement that supply over time.
Drought-stricken Auckland is staring down the barrel of a hot summer after a lengthy and punishing dry spell this year. The super city will be released from the shackles of household water restrictions later this month, but authorities say it hasn't escaped its water woes just yet. The region's dams are just 72% full, when they're usually 90% full at this time of the year. Our reporter Jean Bell and camera operator Dan Cook went to check out whether the city's water supply will last the summer.
In late May, Upper Maungari Dam in the Hunua Ranges was an abysmal 38% full. You couldn't even get a boat onto the dam as the water around the launching ramp was too shallow. Today the dam is 67% full. It is usually around 98% full at this time of year. James Talbot is the operations controller at Watercare. He can get a boat on the water now, but says that's not necessarily cause for celebration.
The dam levels, particularly in the Hunua Ranges and at Maungari where we are today, have come up bit, not a huge amount, but they have certainly increased. We were down well below 50% for a while there.
Auckland Council is scrambling to resolve the super city's water woes. Mandatory water restrictions were enforced in May. People were asked to take 4-minute showers and were banned from using outdoor hoses and water blasters. The council has splashed out $224 million on infrastructure to increase take from the Waikato River and other sources, including the Hayes Creek Dam and a new treatment plant in Pukikohi. Mr Talbot says full-up dams would be ideal, but this increased supply and decreased demand has helped keep things afloat.
The draw off the lakes has been significantly reduced, and that's largely down to the great job Aucklanders have been doing.
But Mr Talbot says Aucklanders can't afford to take their eye off their water usage.
For me personally, I mean, the lakes are still lower than what they would have been prior, so it's still going to be really important for people to maintain those good habits that have been instilled over the last few months.
And he's got some water saving tips for Aucklanders.
I'm a big fan of the additional buckets in the shower, that's for sure, for use elsewhere around the home or house. In addition to that, I think particularly on people that are on, that have high pressure coming out their taps, just being really vigilant about how long those taps are open for and keeping them closed when they're not in use.
Watercare Acting Chief Executive Marlon Bridge says while things have improved, Auckland's not off the hook yet.
Well, right now we're at a comfortable level in terms of where the lakes are at, and demand's been exceptionally good, with Aucklanders saving over 7 billion litres to date. The weather forecasts are also showing positive signs compared to May earlier this year, but in terms of supply, we're well on track with the additional supply, non-dam related, so things are looking positive, but we're not out of the woods yet.
He says Aucklanders have stepped up to the challenge of saving water and they need to continue that.
I think there needs to be this ongoing push that water is a precious resource, and I think people are starting to get that. In Auckland, we haven't had what we've had to date, but then we haven't had the biggest drought in the history of Auckland. So for me, it is, water is a precious resource and we need to treat it with respect.
Water restrictions in Auckland have been eased just in time for summer. But are we out of the woods yet? We hit the streets to find out what Aucklanders think.
Forecast saying we're going to have a long, dry summer. If we use it all now, won't be any left in the summer, and we'll have more restrictions as we move forward into January and February.
We were driving out to Huia and went past the Nehitopi Dam and pulled in and saw that, it looked really, really low, and you could see a whole lot of brown earth that typically wasn't there, and kind of made us realise that it was a situation and it was quite serious.
Ideal would be 90%, but that's very unlikely to happen. But we still need to be respectful. Save water, not waste it, not wash our cars every weekend.
Phil Goff, the Mayor of Auckland, is confident there is enough water in the tank to see the city through the summer.
I have assurances from Watercare that with the extra investment we've put in, new water treatment plants at Pukikohi, about to open in Papakura, further extended in Tuakau in the new year, we will increase overall within the last 18 months our water supply to the city by 96 million litres a day. That, together with the savings that Aucklanders have made, have meant that we haven't suffered what might have been the case given that we had the worst drought in the history of the city.
He's confident further, more severe restrictions won't be slapped back on the city.
We never know what the weather is going to deliver. Every time I'm told that there's going to be rain, sometimes I see, as we did in September and October, some of the driest months on record for the city. But on the combined effect of greater water supply and conservation measures by Aucklanders, I'm confident that we can get through the situation without severe water restrictions.
Aucklanders have been given one small reprieve. The hand hose is back in a couple of weeks, but it has to be used with a trigger nozzle. But with a long, hot summer looming, residents of the city of Sails are being reminded to keep a lid on their water consumption. Mō te hotako o te ahi nei ko Jeanbao tēnei.
Stormwater is rainwater that flows across roofs, roads, and driveways into the stormwater system. It is important to note that stormwater is not treated to remove any pollutants. Wastewater is the dirty water from houses and businesses that is flushed or sent into the wastewater system. Wastewater ends up at the wastewater treatment plant, where the wastewater is treated, solids removed, and the liquid is discharged into the sea. It is very important to manage stormwater and wastewater because healthy water systems nourish the natural environment. The health of our waterways is very closely connected to the activities that are happening on the surrounding land. Some streams are surrounded by native bush and have clean water and thriving animals and plant populations. By contrast, most of our urban streams are in poor health. The health of our rural waterways is mixed, depending on how the surrounding farming, forestry, and agricultural practices are managed. Our harbors and marine waters hold an incredible array of biodiversity, but sediment from land-based activities are muddying the waters and endanger sea life. So what's causing the degradation? It's not a straightforward answer. Sediment comes from land disturbance like earthworks, forest harvesting, and stream erosion and slips. Many other contaminants accumulate from diffuse sources that are difficult to manage, like the heavy metals that come from the pads on your car brakes, and roads act like a pipe for rain to wash these materials into the environment. If you look at the map, you can see water quality is generally better in remote parts of the region and worse in populated areas. There's a direct correlation between population and development and water quality. Storm water affects the quality of our environment as it picks up rubbish over sediment, animal droppings, chemical and other contaminants from roads and other paved areas. And finally, it can be transferred to our seas, which pollutes our water bodies. It is very important for us to manage stormwater because we understand that stormwater is making our environment polluted. There are 3 objectives to stormwater management: minimize flooding, maintain the environmental value of our aquatic habitats, and to prevent the pollution of our seas. There are a variety of methods used to manage stormwater. They include building networks, maintaining infrastructure, that is to reduce flooding, reduce levels of impermeable surfaces, retention, that's permanent storage of stormwater, detention, the temporary storage of stormwater, treatment, reuse, revegetating waterways, and low impact design, that's reducing the amount of runoff after a storm. We will talk about each of these as we move forward. There are a variety of infrastructure-based techniques used to manage stormwater. Stormwater network reticulation is a piped network which carries stormwater. Sometimes the network drains directly to a water body, but other times it can be filtered first. Traditional development approaches rely on vast amounts of impermeable or impervious surfaces. These are hard surfaces which prevent or slow down the entry of water into the soil. Examples include roofs, car parks, and concreted areas. More modern approaches that include better stormwater management incorporate natural ground surfaces, including trees, grass, and soil, which allow water to pass through and soak into the ground, which results in reducing the volume of runoff flowing over the ground. Another example of stormwater management in the built environment is a rainwater retention tank. This is a rain tank which is used to temporarily store rainwater and release it at a slower rate through a specially designed hole. In some cases, the water may be stored and used for non-potable water demands, such as watering a garden. An additional example of urban stormwater management includes biofiltration practices and water reuse. For example, curb cuts or openings can be placed in the curb to allow water to pass off the paved surfaces into a biofiltration practice. This practice allows both objectives, traffic control and stormwater management, to be attained. Using stormwater generated from roof areas or even from impermeable surfaces for domestic or industrial purposes can reduce the total volume of stormwater discharged, as urban reuses is separated from catchment stormwater delivery. Water reuse is potentially a valuable tool in reducing stormwater runoff volumes and has other benefits, which include reduced use of potable water for non-potable needs. Design-based stormwater management is called low-impact design. This is a design approach for site development that protects and incorporates natural site features into erosion and sediment control and stormwater management plans. A few locations in Auckland have incorporated stormwater management design into their overall site plan. For example, the Stonefields stormwater treatment contributes to flood protection from any likely storm for all dwellings within the Stonefields development, a cost-effective stormwater management area which has been provided that maximizes the land available for development, and it also provides a significant community amenity. It also provides an opportunity to educate the community about stormwater within natural and urban environments via signboards. Wastewater, also known as sewage, is used water that goes down sinks, washing machines, showers, baths, and toilets. Most of it is water. The rest includes organic matter such as human waste, food scraps, cooking fats, oil, and grease, and debris such as sand, grit, and plastic. Wastewater may also include household and business chemicals, paint, and medicines. These can be harmful to our health, our harbors, and our waterways, so effective treatment is quite important. There are 3 steps to treating wastewater: primary treatment, secondary treatment, and tertiary treatment. Primary treatment is mechanical and essentially involves separating solids from liquid waste stream, which has 2 additional stages by itself. First, screening. Screening is the first line of treatment at the entrance of the stormwater treatment plant. Here, the solids are removed by filter from the liquids. Second, debris such as plastic, water, leaves, etc. is separated from the waste stream. Third, pre-treatment occurs when wastewater from Auckland's main sewers enters a mixing chamber at the start of the processing. Air is blown into the wastewater to prevent solids from settling out. Gases are extracted at this point and at numerous stages throughout the treatment process and pass through odor control filters. Secondary treatment is carried out in 9 large circular reactor clarifiers. Each reactor clarifier has the capacity to hold 31.3 million liters, equivalent to the wastewater treatment requirements of 200,000 people. The secondary treatment system is known as biological nutrient removal and uses a process known as activated sludge with high levels of bacteria. The system relies on controlled growth of populations of bacteria to biologically strip out organic pollutants, in this case nitrogen and ammonia, and reduce its biochemical oxygen demand of the wastewater. The final or tertiary stage of the land-based wastewater treatment system is disinfection, using ultraviolet light. In this process, clarified sewage from the reactor passes through the disinfection plant.
Back in early 20th century Auckland, people used to leave a bucket of their human waste out in the street each night, ready for collection by a horse-drawn night cart. Luckily for us, we've come a long way since then. These days, our team at Watercare have the responsibility to collect and treat the wastewater produced across the entire Auckland region. Most wastewater comes from toilets, showers and washing machines. The remainder includes organic matter like human waste and food scraps, and things that shouldn't enter our pipes, like cooking fats, wet wipes and stormwater. Wastewater can also include things like household chemicals, paint and pharmaceuticals that can be harmful to our health and to our harbours and waterways. So effective treatment is very important. 24/7, nearly 8,000 kilometres of pipes carry Auckland's wastewater to one of 18 treatment plants throughout the region. Here the wastewater is treated to standards that protect public health, the local environment and our coasts and harbours. It's a responsibility we take extremely seriously. Our smaller wastewater treatment plants serve our rural communities, but most of the wastewater is treated at the Maungari or Rosedale plants. The Maungari wastewater treatment plant is Auckland's largest, and it's one of the most advanced plants in the world. It handles about 3/4 of the region's wastewater and liquid trade waste. Here, wastewater is treated in 3 key steps. First, raw wastewater goes through screens, which removes any solids greater than 3 millimetres. Large stainless steel rotating drum screens collect the material, feed it up a conveyor, and deposit it in a large bin, ready to be trucked to landfill. We find all sorts of things in the screenings process: rags, food scraps, wet wipes, toys, jewellery, false teeth, passports, even cash. The liquid then goes through large sedimentation tanks where sand and grit is removed and sludge sinks to the bottom and is separated from the liquid. In the secondary stage of treatment, we use aeration and pumps to create an environment to grow special bacteria which convert and remove contaminants that can be harmful to the environment. An army of different microorganisms live in these giant reactor clarifiers, eat the carbon and reduce the amount of phosphorus and nitrogen in the wastewater. In the aerobic zones, ammonia and organic nitrogen is converted to nitrates. In the anoxic zones, these nitrates are converted to harmless nitrogen gas. This entire process is biological, which means no chemicals are needed. It's also one of the most dangerous parts of the treatment plant. If you fell into the reactor zone, you'd sink to the bottom, even if you're wearing a life jacket. That's because there's so much air in the wastewater, there's no buoyancy. By now, the liquid wastewater is looking really good, but to make sure it's ultra clean, we filter it and disinfect it with ultraviolet light. It travels through channels where it's exposed to powerful UV light, which delivers a 10,000-fold reduction in the number of harmful pathogens and bacteria. This is an extremely effective method of disinfection, which produces no chemical byproducts and is safe for the environment. After filtration and UV disinfection, about 12 hours after the wastewater entered the treatment plant, and after many stringent quality tests every step of the way, the treated wastewater is safely discharged into the Manukau Harbour on the outgoing high tide. But that's not where the story ends. Solids from the treatment process are thickened and digested to make it safe for disposal. During this process, methane biogas is created, which is then fed into engines to generate electricity for the plant. This produces about 2/3 of our plant's energy consumption, significantly reducing our operating costs. Treated biosolids at our Maungari plant are put to further good use. They're transported to nearby Pukatutu Island, where they're being used to restore a former quarry. Ultimately, it'll be transformed into a regional park for Aucklanders to enjoy into the future. Auckland is a water city. Our beaches and waterways are our jewels. You can feel confident that we are working to protect and enhance our natural environment by treating wastewater to the highest standard. And in doing so, we're meeting all of our consent obligations, but more importantly, we're protecting the health and well-being of our communities.